Okay, so let's take a look at the solutions for practice set 7. The first problem here is a table. The first thing to recognize is that you have the rate there, so that is kind of like the derivative. You have water being pumped in with a given W and water being pumped out at a rate R, right? So these are W is the in, R is the out. The first thing it asks us to do is to estimate R prime of 2, right? So R prime of 2 is going to be approximately, so we don't have the instantaneous value, but we have the ability to approximate this using the values for R at 3 and 4, or sorry, 1 and 3. So R prime of 2 is going to be approximately, alright, so we're using instantaneous rate of change, or average rate of change at R of 3 minus R of 1 over 3 minus 1, which is going to be 950 minus 1190 over 2, which is negative 240 over 2, which is negative 120. Now the unit here should be liters per hour, so you can write that as liters per hour squared. Sorry, in the written form I have it as liters per hour. It should be liters per hour squared, because the R is already in liters per hour, so the R prime should be in liters per hour squared. Alright, so that's part A of the problem. Part B says use a left-hand Riemann sum with 4 intervals to indicate if the table is an estimate of total amount of water removed over 8 hours. So total amount removed over 8 hours should be the integral from 0 to 8 of R of t dt. If you take the left hands of that, you should get 1340 times the width of 1 plus 950 times the width of 2 plus 740 plus 740 times the width of 2. I missed one in there. Let's back that up. 1340 times the width of 1. The next left-hand mark would be 1190 times a width of 2. There we go. Plus 950 times the width of 3 plus 740 times the width of 2 comes out to 8,050 liters. Okay, so we're going to move forward from there. All right, so part C says your answer from part B to find an estimate of the total amount of water in the tank at the end of 8 hours. So that's going to be the amount that we start with, which according to the problem is 50,000 liters, minus the amount that we take out, which is what we just found in part B, plus the amount that is going in, which is the 0 to 8 of W of t dt, because that's an accumulation of a rate. You can throw that into a calculator and you're going to get approximately 49,786 liters in the tank at time 8. So that's part C. Let's look at part D. Part D is interesting. It's like show that there is a time where the amount being pumped into the tank is the same as the amount being pumped out. So what we want to do is we want to create a function that is the difference between these two. Okay, so these things are going to be equal when this is 0. Now we know that if these are both continuous, according to the problem, so P is continuous. We have to state that because that's a precondition to the intermediate value theorem, which is what we're going to use here. You see, we're going to show that P of 0, which is 2000 minus 1340, because we know R at 0 and we can figure out W at 0, is 660. P at time 8 is approximately 81.524. That's the W at 8. And we know the exact value of R at 8 is 700. That's clearly negative. So this one being clearly positive, this one being clearly negative, that means from time 0 to time 8, by the intermediate value theorem, there exists some C, right, on 0, 8, such that P of C has to equal 0, which means at that time, W of C has to equal R of C, which means that at some point between 0 and 8, W has to equal R. So that's an intermediate value theorem problem. All right, so in part 2, they give you a graph of f and an integral of g, which is the integral function of f, and they're asking me questions about that. Part A is asking me for relative maximum, relative minimum, or neither at x equals 10. So g prime of 10 is the same as f of 10, which is equal to 0, which means we got the derivative being 0, which is the first part of the second derivative test. And then if I look at this, g prime of x is negative on the interval from -4 to 10. It's decreasing. F is decreasing. G prime, or F is negative at that point. G prime of x is also less than 0 on 10 to 12. So G is decreasing on both of these intervals. So if G is increasing on one side of 10 and G is decreasing on the other side of 10, this means that G has no local extrema. At x equals 10. All right, so let's look at part B. Does the graph have a point of inflection at x equals 4? All right, so g prime of x is the same as f of x, which means the second derivative of g has to be the derivative of f, which means that g double prime of x is greater than 0 on -2, 4. F is increasing on that interval. G double prime of x is less than 0 on 4, 8, because f is decreasing on that interval. These things together show me that there is a point of inflection at x equals 4, because the sign of the second derivative changes at that location. The concavity goes from being concave up to concave down. All right, so let's look at the next piece. All right, so it's asking me to find the absolute minimum value and the absolute maximum value of g on the interval from -4 to 12. So keep in mind that g prime of x is f of x, and we want to know where that is 0. That happens when x is -2, 2, and 10. So my critical points are going to be the endpoints, -4, the points where it's 0, and then the other endpoint, right? Okay. Sorry, f is also 0 at 6, so let's back this up. I'm going to need a 6 in here as well, right? So 2, 6, 10, and 12. Lots of critical points. All right, so f of -4, sorry, g of -4 is going to be the integral from 2 to negative 4 of f of t dt, which is the same as the integral from negative 4 to 2 negative of f of t dt. So you've got a triangle there with a base of 2 and a height of 4, and you're adding in another triangle that has a base of 4 and a height of 4, which means that we're going to take negative 4 plus 8, which comes up as negative 4. Alright, g of negative 2 is the integral from 2 to negative 2 of f of t dt, which is negative integral from negative 2 to 2 of f of t dt, which is just the negative of the triangle from 4 to with a base of 4 and a height of 4, which means that this is negative 8. All right, g of 2 is pretty simple because that's the integral from 2 to 2 of f of t dt, which is just 0. G of 6 is the integral from 2 to 6 of f of t dt, which is just the triangle with a base of 4 and a height of 4, which gives me positive 8. G of 10 is 2 to 10 of f of t dt, which is that 8 that we just found, right? Minus 1 over 2 times 4 times 4, which is going to give me 0. And finally, I'm going to need g of 12, which is the integral from 2 to 6, sorry, of 2 to 12 of f of t dt, which is going to be the 0, which was 2 to 10, minus 1/2 2 times 4, which gives me negative 4. Alright, so let's take a look at this and see where this scores out. You have a lowest possible value is the negative 8, which is here. This is a little bit messy, but it's there. The highest possible value is the 8 there. So the absolute min is negative 8, and the absolute max is 8. Alright, so lots of scratching out on that one, but we get there. Alright, so that's problem 2. Okay, so there's a part D to the problem. It says find all the intervals for which g of x is less than 0. So you have to do a little bit of thinking here. You have to note that g of 2 from 2 to 2 of f of t dt has to equal 0. Okay. You also note that g of 10 is also 0. Okay, so that should give you a couple of markers that those are the two places where we're going to get zeros. So doing some examination, you should be able to conclude that we're negative on negative 4, 2, and that g is then going to be negative again at 10, 12. So you can use some work from earlier parts of this problem and kind of pull that together. You might have to sit with that one for a minute, but I think it's fairly easy to access once you start with these 2 points. Alright, so let's look at problem 3. Alright, so in this problem you're given a differential equation, and the first thing you have to do is find the second derivative in terms of x and y. Alright, so we have dy dx is x squared minus half y, which means the second derivative with respect to y, or sorry, with respect to x. So this is implicit, so this is 2x minus 1/2 dy dx. gives me this. And then the original statement of dy dx was this. And you can literally stop right there. Now, you can use this information to do part B. Part B basically says you're doing these two things at the point negative 2, 8. So dy dx at negative 2, 8 is going to be negative 2 squared minus 1/2 times 8. So that comes out as 0. And then the second derivative of y with respect to x at negative 2, 8 comes out as, well, 2 times negative 2 minus 1/2 times the first derivative, which is negative 4. This one being positive, that one being negative, gives me local max at that value. So this is going to be a local maximum for this function. Alright, so part 3, or part C of number 3, is a limit problem. Your L'Hopital stuff should be peaked on this. We want the limit as x approaches negative 1 of g of x minus 2 over 3 times x plus 1 squared. Start substituting in the 1. You're going to get g of negative 1 minus 2 over 3 times 0. G of negative 1, though, is 2. So this gives me the telltale 0 over 0. So we use L'Hopital's rule. When we take the derivative of the top, we're going to get g prime of x. When we take the derivative of the bottom, we're going to get 6 times x plus 1. G prime of negative 1 over 6 times 0 again. We know the derivative at negative 1 because that's going to be negative 1 squared minus 1/2 times 2 over 0, which again comes out as 1 minus 1, which is 0 over 0. So we apply L'Hopital's rule a second time. So when we do this a second time, we're going to end up with g double prime of x over 6. We have the rule for the second derivative above, so this is going to be 2 times negative 1 minus 1/2 times the first derivative, which we just calculated as 0, over 6, which gives me negative 2 over 6, or negative 1/3. Alright, so let's look at part D of the problem. Part D is a Euler's rule problem. So, or Euler's method problem. So we have an initial value at 0, 2. So the initial value for x is 0. The initial value for y is 2. Alright, so we're going to do this in 2 steps, and we're going to get to x as 1. So the first step is going to take me to 1/2, which means that my step size is 1/2. So we're going to take 2, and we're going to add the step size of 1/2, and then we're going to take the derivative at 0, 2, which is 0 squared minus 1/2 times 2, just 2 plus 1/2 times negative 1, just 2 minus 1/2, which is 3/2. Alright, so the second step puts me at 1. So we're going to start at 3/2. The step size is 1/2, and then we're going to take the derivative at 1/2 3/2. So that's 1/2 squared minus 1/2 times 3/2. So this is 3/2 plus 1/2 times 1/4 minus 3/4. Let's see, 1/4 minus 3/4 is negative 2/4. So that's negative 1/2. So this is 6/4 minus 1/4 is 5/4. So the value is going to be 5/4 for that problem. So let's move on to part 4 of this whole assignment. Okay, so in part 4, you get this cone. Well, it's not a cone, it's a funnel type shape. They give you the measure of the radius. They say, what is the average value of the radius? Now, you know that the total height of the cone goes from 0 to 10. So average value here is going to be 1/10. The integral from 0 to 10 of this r, which is 1/20 times 3 plus the height squared dh. I actually worked this all out by hand. In reality, for the test, you can put that into the calculator, and you're going to get about 109/60 inches. So you can look at my notes and see how I did work it out by hand, but you won't need to for this problem. Volume of the cone is going to be pi times the integral from 0 to 10 of the radius squared, right? So that's the whole thing squared dh. And again, you can throw that all into the calculator and you're going to get like 2209 pi over 40. Unit here should be inches cubed, or you can get the decimal equivalent of that. Again, I worked it all out by hand, but you can do that using the calculator. So let's look at part C of the problem. All right, so part C is when this becomes a related rates problem. So we're told that we're given that the height is going to be 3 inches. The rate at which the height is changing is -1/5 inches per second. And we want, that's the rate of the radius changing, so we want the rate of the height changing, right? So really, you just use the equation as given. R is equal to 1/20th, so that's going to be 3/20ths plus 1/20h squared, right? dr dt, this is implicit. That goes to 0, so this is going to become 1/10 times h times dh dt. Fill in the blanks. This is a -1/5. That's 10th times 3 times dh dt. Well, let's see. That means that dh dt is going to be -1/5 times 10/3, which is -2/3 inches per second. All right, so that's part C. That one's pretty straightforward. Let's look at part 5. Okay, so problem number 5 here is legitimate for the 2020 administration because they can ask you about a Taylor polynomial. All right, so it asks for the first 4 non-zero terms and for the general term. So we're a Taylor polynomial about 1, so I need f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 times x minus 1 squared. That's going to be over 2 plus f triple prime of 1 over 6 times x minus 1 squared plus, and then we need the general term, which is the nth derivative at 1 over n factorial times x minus 1 to the nth. All right, so let's play this out. F of 1 is 1. F prime of 1 is -1/2. And then we're going to get 1/2 times, that works out to be 1 factorial over 4, so that's 1/4 times x minus 1 squared plus 1/6 times, and then this is -2 factorial over 8 times x minus 1. This one's cubed. And then we need the general term, right? Which we're working out to be negative 1 to the nth. Well, we need a 1 over n factorial, right? Because that's the n factorial there. So 1 over n factorial times negative 1 to the nth times n minus 1 factorial over 2 to the nth times x minus 1 to the nth, right? And then we keep going. So a little simplifying, 1 minus half times x minus 1 plus an eighth times x minus 1 squared. This is going to be a minus, let's see, that's 1 over 24 x minus 1 cubed. And then, let's see, so we're going to get a negative 1 to the nth up top. We're going to get an n in the bottom. There's a general term. 2 to the n times x minus 1 to the nth. And there you go. So there's the first 1, 2, 3, 4 non-zero terms and the general term. Part B asks us to make an estimate using this. So let's do that. So we're using the third degree polynomial to make an estimate. So that's 1 minus a half times x minus 1 plus an eighth times x minus 1 squared. If you throw things in there, you're going to get 1 minus 1 half. So this is when x is 1.2. So 1.2 minus 1 is 0.2. I get a 0.2 here as well. You can literally throw that in the calculator and you're going to get 0.905. I worked it out as a fraction. It's 181 over 200. Either way, that's it. There's the whole problems. I hope this is helpful. If something is confusing, please stop in the drop-in or send me an email, and we'll go from there. Thank you.